Welcome to AI Frontiers, Robotics Research Insights. Today's episode synthesizes key papers from the ArXiv preprint server dated April 28, 2025. The field of robotics, classified as CSRO, integrates artificial intelligence, mechanical engineering, and computer science to develop autonomous systems for dynamic environments. Current research focuses on industrial applications, medical robotics, and household assistance, with particular breakthroughs in locomotion, perception, human-robot interaction, and safety systems. The field of robotics in 2025 centers on creating machines that can adapt to unstructured environments. Applications range from disaster response systems, as demonstrated by Liu and colleagues, to socially aware autonomous vehicles developed by Wang's team. These advancements are driven by two key factors: artificial intelligence innovations like generative adversarial networks and reinforcement learning, coupled with hardware breakthroughs such as energy-efficient pensegrity leg designs. Theme 1 explores locomotion breakthroughs for challenging terrains. Cahill's 2025 study introduces thruster-augmented bipedal robots that can recover from stumbles. Liu and colleagues developed mud-adaptive gaits using proprioceptive sensing, while Mortenson's team created tensegrity legs with variable stiffness that reduce energy consumption by 30%. These innovations significantly improve robotic mobility in unpredictable environments. Theme 2 examines perception and mapping advancements. Davies and collaborators present GAN SLAM, which uses generative adversarial networks to refine noisy maps for architectural applications. Zhang's team developed Armor, a reinforcement learning system that constructs 3D meshes in uncharted environments like caves. Notably, these systems demonstrate how GANs can infer plausible structures from sparse sensor data, effectively hallucinating missing environmental details. Human-robot interaction forms Theme 3. Rayati's research enables now robots to mimic human emotions in real time, while Wang's work focuses on autonomous vehicles that predict driver intentions using directed acyclic graphs combined with deep reinforcement learning. This socially aware approach has been shown to reduce unsafe lane changes by 40%, demonstrating the importance of understanding human behavior for robotic systems. Theme 4 covers grasping and control innovations. Co's team applies SE3 diffusion models to ensure collision-free grasping operations, while Ravi developed Quick Grasp, an antipodal grasp planner that operates in under 50 milliseconds. Technical analysis shows these diffusion model-based approaches outperform traditional sampling methods by 22% in success rates, marking significant progress in robotic manipulation. Key findings across these papers reveal important patterns. Cahill's thruster-augmented bipedalism demonstrates improved terrain robustness. Davies' GAN SLAM proves critical for construction applications by correcting mapping errors. Wang's social intention modeling prevents 40% of potential autonomous vehicle accidents. Together, these breakthroughs highlight the field's progress toward more capable and reliable robotic systems. Several methodologies are driving progress in robotics. Reinforcement learning enables adaptive policies in systems like Artemis and Armor. Neural operators provide scalable safety analysis through approaches like HJRNM. Hybrid models that combine physics with machine learning, exemplified by Feilbert, strike a balance between computational speed and accuracy. These tools collectively advance the field's technical capabilities. The first seminal paper comes from Ye and colleagues in 2025, addressing deformable multibody modeling for legged robots. Their work solves the problem of compliance-induced instability in dynamic gaits by introducing the CCPDR tensor, which unifies rigid and flexible body dynamics. This innovation improves force distribution during trotting by 15%, representing a significant advancement in legged locomotion control. Davies' 2025 paper on GAN SLAM presents a groundbreaking approach to generative mapping. The system uses generative adversarial networks to correct simultaneous localization and mapping errors in real time, achieving 90% floor plan accuracy compared to 70% with traditional methods. This capability effectively allows robots to imagine plausible structures for missing environmental features, revolutionizing robotic perception. Wang's 2025 research on socially aware autonomous driving represents another landmark study. By modeling human yielding intentions using directed acyclic graphs, their framework reduces unsafe lane changes by 40% in simulations. This work lays important groundwork for the future integration of robotic systems into human-dominated traffic environments, addressing a critical challenge in autonomous vehicle deployment. Looking ahead, robotics research faces several key directions. Generalization remains a challenge, with approaches like Nora's imitation learning offering few-shot adaptation potential. Hardware-software co-design, exemplified by Feilbert's hybrid approach, optimizes algorithms for edge devices. Ethical considerations, particularly formal safety guarantees through methods like HJRNO's reachability analysis, will grow increasingly important as robots enter human spaces. 3 key takeaways emerge from today's research synthesis. First, artificial intelligence techniques like GANs and reinforcement learning are revolutionizing robotic perception and control. Second, the synergy between hardware and software enables unprecedented real-world robustness. Third, human-centric design principles are proving critical for successful robotic adoption across various domains. This episode was generated through AI-powered research curation, analyzing 15 paper summaries from the ArXiv preprint server. Technical accuracy was validated by domain experts, while conceptual diagrams were created using stable diffusion models. In this podcast, we bring you the latest breakthroughs in computer science and AI, straight from ArXiv. From neural networks to quantum computing, we simplify complex research so you can stay ahead. Whether you're a developer, researcher, or tech enthusiast, AI Frontiers keeps you informed daily. Thanks for listening. If you enjoyed this episode, subscribe for daily updates. See you tomorrow with more cutting-edge AI insights.